All right, so question two. All right, question two says simplify x squared plus 7x all over x squared minus 49. So what we're going to do here is that we're going to factorize the numerator. So we're going to take out x, and then inside we'll have x plus 7. This is going to be all over the denominator, which is actually x squared minus 49, which is the difference of two squares. So we're just going to introduce two brackets. We're going to put the square roots of the two terms there. So x and 7, we put a plus and a minus in the other one. As you can see here, um, the x plus 7, the x plus 7 could be canceled here. So what we're left with is basically the numerator, which is x over x minus 7. And that is our answer for that. Number two. Number two says here, we want to find the value of r when x squared. So I'm just going to write back this quickly. When x squared times x to the 6 is equal to x raised to the r. So basically, we're going to work out the left side. When you multiply the same base, you add the exponents. So what we have here, this is going to equal to x raised to the 8, which is equal to x raised to the r. Since both base is actually x, then the exponents are the same. So we could just verify that r is equal to 8. We're still solving for x in this case where x raised to the third is equal to 8. In order to find this, all we're going to do is just to find the cube root of x to the third, balance the equation by finding the cube root of 8. The cube root and the cube would cancel, so this goes. So we're now left with s is equal to the cube root of 8 is 2. What that means is that 2 times 2 times 2 would give us 8. All right, so the answer is 2. All right, let's keep going. All right, so in this case, what we're looking at is, all right, so here it is. It says the diagram below shows a triangle and a quadrilateral. All angles in degrees are written in terms of A and RB. First question is that we're supposed to find for the triangle, show that 2A plus 5B is 171. So what we're going to do here is to take these angles of the triangle, we're going to add them, and it should come to 180 degrees. So let's go. 3B plus A plus 2B plus A plus 9 is equal to 180 degrees. We're going to simplify this by putting together the like terms. So let's look at the A's. All right, so we're looking at the A terms. So for the A's, I'm having A plus A, which is going to give me 2A. And for the B's, I'm having B's. So we're talking about 3B plus 2B, that's 5B, plus 9 equal to 180. Then we're going to subtract 9 from both sides. So 2A plus 5B is 171. Hence, we would have proven this. Now, let's go to the next one. The next one says here, we're dealing with the quadrilateral. So with this quadrilateral, we're looking at um, this angle here, plus this angle, plus this, should give us, when we add them, we should get 360. So let's put them together. We have we have 6A plus 3A plus 2B plus 3A minus 3B minus 2A plus 18 plus 3b. This is 360. Let's put together the terms that are alike. A, A, A. So what we're looking at there is actually 9a minus 2a. So this and this, that's 9a minus 2a. It's going to give me 7a. Let's take a look at the b's. So 2b plus 3b, that's 5b plus 3 more. That's going to give me 8b. I'm going to subtract the 18 from both sides right here. So this is going to equal to 360 minus 18 is 342. Hence, we would have proven this one. All right, let's keep going. The question says, solve a pair of simultaneous equation above. So basically then we're looking at 2a plus 5b, 2a plus 5b, which is equal to 171, and then 5a plus 8b is equal to 342. What we want to do is just to make sure that the numbers are good. All right, the numbers are good. So I'm going to eliminate a's first. So I'm going to take those coefficients of the a's. So the 5 is going to multiply here, and the 2 is going to multiply here. Oh, this is 7. Let's go back. 7. All right, guys, give me a minute. This here is a 7. All right, so let's do this. So this is 2a plus 5b, which is equal to 171. And then the second equation is 7a plus 8b, which is equal to 342. I'm going to eliminate the a's. Remember, this is equation 1, this is equation 2. So I'm going to multiply 7 by equation 1 and 2 by equation 2. So in creating equation 3, 7 2s, 14a plus 35b, which is going to equal to 171 times 7. That's going to give me 1,197. This is the third equation. 2 times 7 is 14a, 16b, which is equal to 8. Well, not 8, 6. That is equal to 684. That's equation. So all I'm going to do is I'm going to subtract both equations. So if I subtract, this is gone. So 35 minus the 16 is 19b, and this is equal to, when we subtract the others there, we're going to get 513. And if I divide both sides by 19, it is saying that b has a value of 27. Now, I know that b is 27. So b is 27 here. Now, since b is 27, what I'm going to do is I'm going to take any one of these equations. I'm going to take the first one, 2a plus 5b, and this is equal to 171. I'm going to substitute 17 for b, so we're going to have 2a plus 5 times 27, and that is going to equal to 171. So 2a, 27 times 5 is going to give us 135. So we subtract 135 from both sides. And it's saying here that 2a is equal to 36. So if I divide both sides by 2, a is equal to 18. So the solutions are a is equal to 18 and b is equal to 27. All right, let's jump to this other one. So it says here that the diagram below shows a equilateral triangle, FGH, whose base is 13 and its height h. Calculate the value of h. All right, they did tell me that there's a right angle going on right there, and which means that this is the height, and the height is always at right angle. With a equilateral triangle, all the angles are 60 degrees, but I'm just going to focus on this triangle right here. I'm just going to focus on one of them, right? So I'm going to focus on this one right here. So if I focus on that, definitely, I'm just going to put 60 degrees here. And also, I want us to be aware of when we have an equilateral triangle, the base normally hit the height normally hit the base of at 90 degrees, which means that it definitely split the base into two equal pieces. So then this distance here would now be 6.5, which is a half of the 13, right? And over this side, if you want to look at it, would be 6.5 as well. All right, but I'm focusing on this side just to solve the problem, right? So in order to find h, I'm going to use my SOHCAHTOA. So in using that, I'm going to pick the one that is dealing with adjacent and opposite, which is tangent. So the tangent of an angle in the right angle triangle is the opposite side divided by the adjacent side. In this context, the tangent of 60 degrees is equal to h, which is the height that I need, which is the opposite side, over 6.5. At the end of the day, if we multiply both sides by 6.5, you could see here where tangent 6.5 times the tangent of 60 is going to take us out. And that response is 11.258, all right, centimeters. All right, so I'm just going to use three significant figures. So it's going to be 11.3 cm. All right, let's take a look at this. All right, so for this one, the diagram below shows three triangles, PQ and R. Triangle Q and R are image of triangle P after it undergoes a double transformation. So we're seeing the triangle, let's see what they want. Describe fully as the single transformation that maps triangle P onto R. So we're going to be relating P and R. So this is triangle P, this is triangle R. All right, so when you look at this quickly, it's a translation because we're seeing that everything set the same way, orientation, shape, everything. So it's a translation. Now, because it's a translation, I need to tell the components for that translation. It's a vector, so I need those components. So I'm just going to pick on one aspect. Like I'm going to pick on this aspect and figure out how did it move from here to here, right? So I'm just going to do that quickly. So I could just use my walking. Like I'll go to the right one, two places. So that's a two at the top. And when it lines up, I'm going to walk up four. One, two, three, four. So the translation was a 2, 4. I only need to pick on one point because all the other points were affected the same way. So quickly, a description is that from P to R is a translation. T is 2, 4. All right, let's see the other question. R onto Q. So now the focus is on R onto Q. So we're going to be looking at how do we move from R onto Q. All right, so a quick observation. It's not a translation because you could see the object flip. It does look like a reflection, and where this is the mirror, because whenever we have a reflection, we need to find the mirror image. And this is where x is equal to 1 right there. So definitely this is a reflection in the line where x is equal to 1. All right, so you could see our corresponding parts would have linked, that sort of thing. You could see that. You could see, right? So it is a reflection. So it's a reflection in x equal 1. So this was a reflection in x equal 1. Number 4 is a function, and it says f of x is equal to 2 minus 5x, and h of x is equal to 5 raised to the x. Calculate the value of f of 4. So f of 4, simply, let me just write the f function quickly. F of x is 2 minus 5x. So f of 4 would mean that I will substitute 4 in the f function. And then I keep working. So then 2 minus 20 is negative 18. So f of 4 is negative 18. The next one is h of 0. So I'm going to write h of x, which is 5 raised to the x. So h of 0 is 5 raised to the 0. And based on the 0 exponent rule, anything raised to the 0 is 1. See, I'm writing back 5 by error. Anything raised to the 0 is 1. Here we're doing a composite function where we're supposed to find f of h of negative 2. In doing so, I'm going to focus on h of negative 2. And whatever response I get, I'm going to plug that into the f. So remember the h function says h of x is 5 raised to the x. Now I'm going to find h of negative 2 right now. So h of negative 2. Remember the negative exponent rule says that this is the inverse, which means 1 over 5 squared, which finally means 1 over 25. So then this is h of negative 2. Now I'm going to plug 1 over 25 in the f function. So let us write the f function over here. So f of x is equal to 2 minus 5x. So if I'm going to do f of 1 over 25, then it means then I'm going to put 1 over 25. So I'm going to multiply 1 over 25 in the f function. So as you could see right here, we could do some quick canceling. 5 into itself, 1. 5 into 25 goes 5 times. So what we really have here is actually 2 minus 1 over 5, okay? Now, you could look at it. 2 minus 1/5 is simply 1 and 4 over 5. Imagine you have two things and you gave away 1/5. You're left with 1 and 4/5. So we could just easily write that just like that. So in conclusion, we could write the final thing that f of h of negative 2 is 1 and 4 over 5. Some people may see it as 9 over 5, same thing. Now, I'm going to do the inverse of the f function. So here, remember, f of x is equal to 2 minus 5x. I'm going to say let y equal to f of x, all right? Such that y is now equal to 2 minus 5x. Remember when we're doing the inverse, we're going to switch x and y. So this becomes x equals to 2 minus 5y. And then I'm going to transpose to make, y the subject. And if I want a positive y early, I could just simply get this on that side and then get the x on the other side, right? So I'm going to have a positive 5y here, which is now equal to negative x plus 2. And then I'll divide both sides by 5. And then y is equal to negative x plus 2 all over 5. But at the end, I need to respond to the question. The inverse of f of x is negative x plus 2 all over 5. Now let's take a look at the second question, the last question. f of x is a plus bx. Determine the values of a and b. What I'm going to do is just to take this composite function and represent it and see what it is, and then we equate. So remember that the f function is really 2 minus 5x. Now, if I'm going to do of f of x, then it means then I'm going to input the f function in itself. So right here, I'm going to have f of x right here. As we go, it simply means that I'm going to have 5 times the f function, and the f function is actually 2 minus 5x. As you could see, we're required to quickly distribute the 5 inside. So let's rewrite. So this is 2. 5 times 2 is going to give 5 times this 2 inside is going to give me negative 10. And well, I should say negative 5 times 2 is negative 10. Negative 5 times negative 5x is positive 25 with the x. Now, if we simplify this, we're going to have 2 minus that. That's going to be negative 8 plus, so this is negative 8 plus 25. So we have negative 8 plus 25x. Now, this is f of x. Remember that we were told that this is equal to a plus bx. So we could take a look at this. Negative 8 plus 25x. And then what we're going to do is to just make some quick comparison. So this 8 is like the a. So we could say a is equal to 8 because there's an equal sign that comes. That means they are the same. This positive 25 in front of the x is like the b. So it's going to be that b is equal to 25. And there you have it. All right, number 5 is statistics. It says the mass m in kilometers, mass m in kilograms of 120 newborns at a hospital is recorded in the table below. So you're seeing the table. All right, state the median class. Median simply means that the class that occurs the most. So from this column, the frequency, I'm going to look to see the biggest number, which is 30. So I'm going to use it to help me to pick up the median class. So the median class is where m is less than or equal to 5.3, but greater than 4.4. Right? So that's the median class. All right. That's the modal class, my bad. Modal class. Modal class. Thank you. The next question says, complete the table below and calculate the estimate of the mean mass of the 120 newborn. So in completing the table, what we want to do is to fill out the mid, we're going to fill out the mid values here and here, and then we're going to fill out the fx column here and there, and then we deal with it. So let us go. In order to find there are more than one ways to find the mid value, but you could add the two intervals. So 5.3 plus 6.2, and then divide it by 2. And we're going to get this as 5.75. And if you look, there's a pattern I could say that this is going to be 7.55 if you look at the pattern. All right. Or you could add and divide, same thing. We're going to multiply though. We're going to multiply these to get that. So 5.75 times 29, it's going to give me 16.6, no, 166.75. And then if we multiply this 7.55 times 8, we're getting 60.4. So what we're going to do now is to run our total. The total frequency is 120 newborns, so we know that we have to accumulate the other one, right? So we're going to add 21.35 plus 71.1 plus 145.5 plus 166.75 plus 186.2 plus 60.4. So this comes up to 651.3. So those are my totals down here. Now remember that the mean, and some call it X bar, is equal to the sum of Fx over the sum of F. In this context, it's 651.3 over 120. And I'm getting 5.4275. If I want to round this off to three significant figures, I'll use 5.43, right? And it is in kilogram because it is the mean mass, okay? All right, let's keep going. Now, it says one newborn is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3 kilograms. So what we're going to do is go to the table and we're going to look for the masses that are greater than 5.3, greater than 5.3, all right? So let's take a look. Greater than 5.3. All right, you could come here and take a look. Or yeah, this is a little bit clearer. So from this, we're looking at where M is greater than 5.3. So it's going to be everything from here all the way down, right? So what we want to do is to add the 29 plus the 28 plus the 8. So we're going to be adding those, and that value will give us the number that we need to answer the question, right? It's 65. So here it is that when we put it together, we're getting a total of 65, but it's probability. So it's going to be 65 out of the total. That's 120. And you could break this down some more. Let us say you break it down using 5. So 65 divided by 5, you get 13. 120 divided by 5, you get 24. Okay. So if you give that, you're good. If you give that, you're good. All right, let's keep going. All right, complete the cumulative frequency table. What a cumulative frequency is, it's adding up the the frequencies. That's all. So we're adding the frequency. So we just want to take a look. So as you could see, we are at 55, right? So we're going to keep adding, which is a third. So let's look. So as you could see, if you should add this plus this, that's your 25, and 25 plus 30, that's 55. Now we're going to add 29 to it. So we're going to be adding 29 here. It's like we're going to add 29, so plus 29. So we add 29 to that. 29 plus 55, and we're getting 84 for this spot. Keep adding as we go. And then we're going to add 28. So we're going to add 28 to this, plus 28, and this is 112. And then we're going to add the last one, I think it's 8. We're going to add 8. You're adding 8 here. You're going to get 120. And as you could see, it is giving your total, which is 120. That means everything is good. All right. So there it is. We actually have a completed table, cumulative. All right. There it is. Let's keep going. All right. So now what we're going to do here, what we're going to do here, it says on the grid below, draw a cumulative frequency curve um, to show the information in the table. All right. So we're going to try to drop this, right? Drop this information on. All right, there it is. So let us quickly do this. So the cumulative frequency curve, you must use the cumulative frequency. Let me see if I have the table here. All right, so I need the table with the cumulative frequency. All right, maybe we'll go back and forth right here. All right, give me 1 second. Let me just. All right, let me just put the table where I can see it. All right. All right, so let's go. All right, so they had plotted some for us. Sorry, they plot 3. So we're going to plot ours. So one of the things that we want to do is take a look at these small lines here. And I could tell you that based on what we look at, we're seeing where one of them represent 0.1, right? One of them represent 0.1 because this is 2.5 to 3.5 and it's divided into 10 equal pieces. So each one is 0.1. So we can easily navigate this. So let's go for it. So we're going 6.2 to 84. 6.2. All right, so 6.2, I'm following here. This is 6. 6.2 is this line. And I'm going to take this line to 84, up to 84. So we want to look where 84 is. So we're going by 2 on the y-axis, right? So this is 80, 82, 84 is right here. That's 84, right? So that's 84 right there. All right, let's look at the other one. 7.1 to 112. 7.1. 7.1, this is 7. This is 0.1 here going up. And we're going to go to 112. This is 110. 112 is right here. And then the last one, it's 8 to 120. So 8 to 120, this is 8 right here. And 120 is right here at the top. All right. So we're going to try to draw this curve as best as I can with my free hands. All right. All right. So that's basically it right there. So there is a cumulative frequency curve that we're asked to draw right there. So let's just step up the questions now. All right. So that's a cumulative frequency curve. So the next question says, use your diagram to find an estimate for the median mass. The median is the middle, all right? And the middle is 50% of your sample. The sample is 120, 50% of that is to divide it by 2, you're going to get 60. But that's not the answer. You're going to have to take 60, right? You're going to take 60, and you're going to follow your 60 to the curve. So you'll take a straight line, and you follow your 60, you go across like this, right? And right where it touches the curve, which is right here for me, you're going to take it down, right? You'll take it down. I'm getting a 5.6. So the thing is, when you do these though, CXC would know that when you join your freehand, some persons would have a slight bend, some may not. So the truth is there's a range of answers that they have, but everybody's answer should be very close though. So mine is 5.6, all right, kilogram. That's my median, 5.6. So anywhere in the 5.5, 5.6, maybe 5.7, or maybe 5.4, right there. So I'm thinking 5.4 to 5.6 or 7 would be an acceptable answer, right? Right there. All right, let's look at number 6. So number 6 is a measurement, and it reads, it says, the diagram below shows a hemisphere. A hemisphere is half of a sphere. So a hemispherical bowl and a cylindrical tin. The diameter of the cylinder is 12 centimeters. The height is 17. The radius of the bowl is R. We're seeing that. Show that the volume of the cylindrical tin is 1,923 cm cube, and want to give our answer correct to 4 significant figures. So all we're going to do is to use the formula for the volume of a cylinder. So the volume of a cylinder, right, is going to equal to pi r square h, where pi was given as 22/7 in this. So as you could see right here, we got pi 22/7. R. R in this case, this is diameter, so R is going to be 12/2, and so R is 6, so it's going to be 6 square, and you're going to multiply this by 17. We carry out this, and we're going to have the volume of the cylindrical tin, all right? So let's go. So we work out our maths, yeah? So I'm getting 1,923.42. But they did say to 4 significant figures, which is going to be equal to 1,923 cube cm. So right there, we just proved what they said. So let's see what else they want. The bowl is completely filled with soup, right? When all the soup is poured into the empty cylindrical tin, 90% of the volume of the tin is filled. Calculate the radius of the bowl. The volume of the sphere is this. Now, the thing is, we don't have a sphere. We have half of a sphere, right? We have half of a sphere because the bowl is half of a sphere. But we're going to see how we're going to work this out. All right, firstly, we want to make the association that 90% of the cylinder is actually when the bowl is full. So basically then, we want to find 90% of the volume of the tin, which is what we have from the previous question here. All right, so when you work out this, the number that we are going to get, all right, when we work out 90% of this, so let me work this out quickly. All right, so this is giving me 1,730.7 cm cube. This is actually the volume of the bowl. All right, and that bowl is is half of a sphere. So then let's take a look. We're going to be using the volume for a sphere. Let's take a look at the association. So if we come here, we're seeing where the question was dealing with half. We found that this is 1,730.7. Now we got the formula for this, which is the full thing. So we're going to have to double this, right? So if we're going to use that formula, we're going to have to double this idea. And when we double this idea, we're going to end up with this, right? So if we multiply this by 2, we're looking at this to have a volume of 3,461.4. So we're going to be using that. So let's go. So now we just agreed that to work out the volume of the sphere, we're going to have to multiply this by 2. So we work out the volume of the sphere. That's why we're going to use this formula. So this is the formula for the sphere. Basically 3,461.4 is equal to 4/3 pi. I'm just going to start substituting. Pi is 22/7. Hold on. Where's my eraser? All right, let's go. So we're talking times 22/7 times r to the third. Now, in this case, as you can see, what we want to do is work. Let's take one more step. I'm having 88/21 right here. And this is r cubed. So I'm going to multiply this side by 21/88. So that this would cancel this, and the 21 would cancel 21. So I'm going to multiply this by 21/88. All right. So let's see what we have. So 21 times 34, 61.4 divided by 88. What I'm getting over this side is that 826.0, so 826 is equal to r to the third. All right, so then I'm going to have to take the cube root in order to find the answer, right? Because it's raised to the third power. So the cube root of 826 is giving me that r is equal to 9.38 centimeters. So 9.38 centimeters is the response right there. Let's keep rolling. The next question says here, in the diagram below, points L, M, and N are on the circumference, as you could see, of a semicircle with center O, radius R. So radius is 18. So what it means then is that this is 18. It means that this is 18. It also means that this is 18. Radius 18. Now, because of that, we can make a lot of conclusion here. It said calculate the volume. Calculate the total area of the shaded section, my bad, area of the shaded section. So basically, we're going to find the area of the semicircle, find the area of the triangle and subtract. So we could write that the shaded region is equal to the area of the semicircle minus the area of triangle. So let's find them. Let's find the area of a semicircle. That is going to equal to pi r squared over 2, 22 over 7. All right. I'm going to put the half, that's my half, times 18 squared. Okay. So that's pi r squared divided by 2. All right. And I'm getting, for the semicircle, I'm getting the area of 509.14. All right, so that is the area here, right? Now for the triangle, we put the triangle right underneath this. The area of the triangle, we already know. It's simply base times height over 2, or half base times height, the same thing. The base is going to be 18 plus 18, which is going to give us 36, times the height, which is 18, half of that. So 36 times 18 divided by 2, we're getting the area of the triangle to be 324. So now the shaded region, I could come back here, area of the circle, area of the triangle, and we're done right there. So this is giving me 185.14, the unit square cm. So that's the answer right there. All right, let's see what else. All right, it says the diagram below shows the first three shapes in a sequence, right? Show the first three in a sequence which forms a pattern and so on. All right, so we want to complete the fourth one, but we have to take a quick look at what's going on. So as we could see here, we're seeing black and white, that's one. And we're also seeing where for every shape, we have one more layer of white. So shape one, we have 2 layers of white. Shape two, we have 3 layers of white. Shape three, we have 4 layers of white. So with shape four, we're going to have 5 layers of white. That's one. Another thing, look at the blacks. Shape one, we have 2 layers of black. Shape two, 3 layers of black. Shape three, 4 layers of black. Shape four should give me 5 layers of black. Okay, so what it means then I'm going to have more layers. This is going to be a black layer. This has to be a black layer. So we have this is a black layer right here. But there is something else that's going on. Take a look at the numbers. 1, 2, 3, 4, 5, 6, 7. So it's like 3. Look at these, the bottom layer. 3, 5, 7. This should be 9 for me now. That means I'm going to have to put one more here and one more here. Top it off right here. Can't miss this. And then I'm going to have layers now of, so I'm going to have white ones and an extra one here to fill out the gap. Have to observe. If not, we can easily make a mistake. There it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Should have 9 because this was already 7 and it's going up. That's 5. That's 3. So I'm looking at 9 here. So this is what we should draw to get that 4 shape. All right, let's see what's going on. Let's observe the table. So in the table, it says here, um, we have shape N, which is S. So that means for the first S, when S is 1, when S is 2, S is 3, S is 4, we're seeing what's going on. Let's take a look at what they want us to do. 1, in this layer, I'm right here. They want us to fill in this. But when you observe, though, take a look. You could see that with the third layer, you're looking at 3 plus 1 here. With the second layer, 2 plus 1, 1 plus 1, and this is where they're squaring. But you could see that it's 3 square, 1 more than 3 here. So in this case, we're talking about it's going to be 4 plus 1. You're going to have 4 plus 1, which is basically 5 square, and it's going to give we 25. But you could have seen that, it'll give us 25. You could see that these are square numbers coming down. If you're looking at it, you would have seen square numbers. So nonetheless, you should be able to at least get that, right? All right, let's keep going. All right. Now, over here, if you look though, 4 plus 6, that's 10. 15 plus 9, that's 24. So you add. So if I should add these, right? So if I'm add the number of black with the number of white, I should get the total. So 45 plus 25 is going to give us 70 for that one. All right, let's go. What it means now, if we're going backwards, right? If you're going backwards here, we want to fill out this spot right here. If I want to fill that spot right there, I could subtract from the total the black and I'll get the white because we add to come here. So I could subtract. So I'm going to take 144. So 420 minus 144, it's going to give me 276 for this. This is 276. And where is it coming from? Here, right? Now you take a look here as well. This here, right, was actually 11 plus 1 because this is the square root. This is square, the 12. This is 12 square, all right? And based on what we're seeing here, there's 1 which is always added. That means this is 11th shape that we're looking at because 4 plus 1, 5, 3, 3 plus 1, 4. So we're seeing that. So what I'm going to put here, though, is that we have this right here, just like that, right? So let us now put in the other parts. So if we have n, so we want to take a look at what's going on. If we have n here, look at the pattern, right? N, 3 plus 1. So this is going to be n plus 1 right there, right? So 2 plus 1, 1 plus 1. So n plus 1. And then right beside it, the number 2 is always there for everybody. So this is going to be a number 2 right here. Number 2 is here for everybody. But 2 what? 2 times 3, 2 times 1. So this is going to be 2 times n. And behind it is a plus 1. That's what is going on there right now, right? Now, if we want to flesh this out, like to put the final thing, we're talking about distributing. So we'll have, I'm just going to write the final thing for it. Hold on. 2n squared plus 3n plus 1 right? If I'm supposed to just finish that. What do we have here in terms of what should be squared? It is going to be 1 more than n squared. So it's going to be this that was squared right here. Take a look. This that was squared. So it's going to be n plus 1 squared. All right, that's what we're looking at there. And that's that, which is going to give us n squared plus 2n plus 1. And then you could see if we should add these. I'm just showing you something that it's going to give you that, right? So let's go. So basically, we completed the table right there. So it says here the expression for the total number of counters, T. Okay. So we're talking about the white counters plus the black come together. All right, in shape. S is given by, okay, yeah, it's given by this. So this is okay. All right, so we're saying this is the total is gonna give us A, which is S squared plus B S plus 2. Okay, so that's the total. All right. So by substituting a value for S, that means whichever S we're dealing with, whether it's the first, the second, the third, the fourth shape, we substitute there and show that the total is going to be these. All right. So the first one we want to look at when S is 1. Right. So when S is 1, we're going to take this, which is A1 square plus B times 1, because it's the first and X is 1 plus 2. This should equal to the total we have for this column here at the first level. So at the first level, we're dealing with 10. So this is equal to 10. So I'm trying to take this and prove. So this is 10. So if we simplify this, 1 square is 1. 1 times A is still A. 1 times B is still B plus 2 equal to 10. If I subtract 2 from both sides, then A plus B is equal to 8. Hence, I would have proven this one already, right? Was the first shape. So now we're going to focus on shape 3. So in shape 3, we're saying that S is going to be 3 here. Now let's take the idea. The idea says here that A S squared plus B S plus 2 must equal to the total. And we want to find what's the total for the third layer, right? The third layer, we're focusing on this. We're dealing with 44 right there. So let's go. This should equal to 44 right here. Let's substitute 3 where S is. So this is A. We're going to have 3 raised to the second plus B times 3 plus 2 is equal to 44. So 3 is 9. So this is 9A plus 3B plus 2 is equal to 44. I'm going to subtract the 2 from both sides, simplify this, and 9A plus 3B is equal to 42. So when I look at it, it's not what I want yet, but if I divide everything by 3, 3 into 9A, we're going to get 3A. 3 into 3B, we're going to get B. 3 into 42, we get 14. All right, so definitely we just proved this one now. There it is. All right, so that's what they wanted us to take the first shape, the second shape, and prove these. We're done. All right, let's see what's going on here. It says the diagram below shows a graph of 2 functions on the same. All right, so we have G and H. It says here, each determining the equation that represents line G. Now, the line G, as you could see, we have a point here, and this point here is -6, right? And we actually have a point here, which is actually 0, 3. Now, there are many ways you could work this out, right? Looking at this, this is a right angle because it's the axis. This distance is 6, this distance is 3. So technically, my slope, right, which is my gradient here, without working, my gradient is 3 over 6, which is 1/2. So right now, by using this, I'm seeing that the gradient is 1/2. Now, if I know that the gradient is 1/2, okay, I'm almost there because the equation that I'm going to use to write what I'm going to use, the format is I'm going to use a slope-intercept form where y is equal to mx plus c. So in this case, my gradient, I have that. This is 1/2. And c is where it crosses the y-axis, which is actually at 3. So technically speaking, this is simply y is equal to 1/2 x plus 3 right there. So there it is. I have g, right? So I have the equation for g right there. Let me just drop it here. Y is equal to 1/2 x plus 3. All right. It says, want to determine the equation of the line represented, h. All right. So let us look at h. What's going on for h? We're realizing here that h, right? We're realizing here that h, clear up this a little bit. We're realizing that h is definitely perpendicular to g. And then h, this is a point that h, which is on h, which is 4, 0. So technically, when lines are perpendicular, one gradient is the negative reciprocal of the other. So the gradient, the gradient of h is going to equal to 2 over 1, and it's going to be negative. So we could just say -2, right? Because we're going to reciprocate the other one that it is perpendicular to and change the sign. So now it is I have a slope or a gradient and a point. Let's go for it. -2 for 0. So I'm going to take these. I'm going to take m, which is -2, and I'm going to take 4, 0. And I'm going to put it in the format. Y is equal to, let me see if I have where it crossed the y-axis. No, we don't. So I'm going to put it in y equal to mx plus c form. And I'm going to find the y-intercept, which is c. I don't have that. So I'm going to take this. This is x and this is y. I'm going to substitute, right? So in my substitution, the 0 is equal to -2 times 4 plus c. So 0 is equal to -8 plus c. So as you could see, c is equal to +8. So now I could write the equation. The equation is y is equal to -2x plus 8. All right, so there it is. That's my equation. Now the next one says coordinate of the P showing all working. Oh, we want to determine the coordinate of P. Where's P? Okay. All right, so we want the coordinate of P showing all working. The coordinate of P is simply where the two equations are equal, right? Because at every given point, one is greater than the other, right? One is greater than the other until they intersect, right? So wherever they intersect. So what I'm going to do is to find where they are equal. And when they're equal, it's going to give me the coordinate here and the coordinate there. And that will be the solution, right? That's going to be the solution of where they intersect is the coordinate of P. So let's go for that. So let's write the two equations. So the two equations must be equal. So one of them is y is equal to -2x plus 8. And the other one is y is equal to -1/2 x plus 3, right? So where these things are equal, that's where they meet, right? So -2x plus 8 is equal to -1/2 x plus 3. And this is where they actually meet. So what I'm going to do is to gather my x's on one side. So I'm going to be adding, so there are various ways to do this. I'm going to be adding this to the other side, right? So -2x plus, hold on, this is positive, my bad. Hold on, this is positive. I wrote negative here, so let me fix this quickly. Let me look if I really wrote negative up in the question. Let me see if I wrote negative in the question. Oh, it was positive. So I just wrote the negative by error here. All right, good. So this is it. My bad. Let me fix this. So both of them should be equal, which is negative 2x plus 8, which is equal to half x. Very good. Right? So I made a quick error here, but that's fine. So negative 2x plus 8 is equal to half x plus 3. So if I subtract half x from both sides, I'm going to have negative x minus half x plus 8 equal 3. All right, equal 3. And basically, this is negative 2.5, right? That's negative 2.5. Over here, this is negative 2.5 x, which means that it's negative 5 over 2 x, or negative 2.5 x, any way we want to look at it. And we're going to subtract 8 from both sides. And this is going to give me minus 5, okay? So then you could see how we want to do this. It's up to us. This is the same thing as negative 2.5 x equal to negative 5. So let's divide both sides by negative 2.5. All right. So 5 divided by negative 2.5. All right. So that's going to give us positive 2. This is where 2. So this is saying x is 2 right here. All right. So let me write this. X is 2. All right. So what we're going to do is we're going to substitute 2 in any one of these. Anyone. All right. So let us say I take this one. Say I take this one without the fraction. I'm going to put 2 right here. So y is equal to negative 2 times 2 plus 8. So I'm substituting. So y is equal to negative 4 plus 8. Y is equal to 4. So x is 2. The coordinate of p is 2, 4. All right. So let's take a look at where it's located. So you can see almost a half of that. This is 2, a little above the 3, 4. That's what we're saying. 2, 4. All right. All right. So we're good with that. Next question. It says, write 4x squared minus 2x plus 31 in the form here. So this is the completed the square form. It's up to you. I'm just going to drop your formula quickly. H is actually b over 2a. So A is equal to 4, B is equal to negative 24, C is equal to 31. So I'm going to just use a formula quickly to write this out. So H is equal to B over 2A, which is this H that I'm going to be finding like right now. All right. So that is going to equal to negative 24 over 2 A, which is 2 times 4. So basically, we're looking at negative 24 over 8. Divide this by 8, you get negative 3. So H is negative 3. So we have the H value. Let's find the K value now. K is equal to B squared, hold on, 4AC minus B squared all over 4A. And this is going to equal to, let me write this better. It's ugly. So it's going to be 4 times A, which is 4, times C, which is 31, minus B squared, all over 4 times 4. What are we getting here? Let's use our calculator. So 4 times 4, that's 16 times 31. This is going to give us about 496. And it's going to be minus 24 squared. And then that's going to give me 576 all over 16. So let's do this. 496 minus 576, negative 80. Or this is going to give negative 5. So this is negative 80 over 16. So that's negative 5. All right. So here we have it that K is equal to negative 5. So then in the format, we're just going to just substitute. A is 4, X is always here, H is -3, square is always there, K is -5. So here it is. All right, so I just use the formula quickly, and we find that we're done right there. All right, so there it is. There it is. There it is. There it is. Let's keep going. All right, so the question says on the axis below, sketch the graph of that indicating, so we want to indicate the coordinate, the maximum slash minimum. Okay, this graph has a minimum because A is positive, so it's going to smile. Um, and the y-intercept. Okay, the y-intercept is actually positive 31. It's coming from the original thing. All right, so let us deal with it. So if I'm going to sketch this, where's it? All right, let me write it down here so I could look at it. We're looking at 4 open bracket x minus 3 squared plus 31. All right. Why are at 31? Minus 5, right? Yeah, that's it. All right. So here's the thing. First, this is going to help us define the axis of symmetry. It's the opposite of this, so it's at 3. All right. So the axis of symmetry is at 3 right there. All right. So it's at 3. All right. So there's a line here that the axis of symmetry is going to be on at 3. Positive 3. All right. And then the minimum is going to be -5. The minimum is always this value outside here. So that's a -5. So it is somewhere down here. I'm going to put this in red. That's my minimum, -5 right here. Right here is where it's going to turn back, right? That's where it's going to turn back. And so we're looking at a graph that does like this. This is a graph that does something like that. Wherever it crosses here, that's where you're going to put 31, right? Or if you don't like how it's shaped, you could redraw it. But wherever it crosses the y-axis, you got to put 31. It's a sketch, okay? So it's not like in scale, but basically that's the idea, right? It crosses it above the x-axis. Wherever it does, it is 31 up there. So basically that's the sketch where they want us to show the minimum point. So this minimum point is 3, -5 right here. That's 3, -5 right here, right? And that's the y-intercept. So we would have cut that. This is minimum, right? And that's it. State the axis of symmetry. It's where x is equal to 3. And when they said the equation, if you don't write x equal, you're not going to get it, right? Equation needs an equal sign. All right, let's see if we could run through this. This one says given that. All right, so we have information that they give here. Let's see what they want. Find the value of the angle KOL, giving reason for each. KOL. All right, so let us mark KOL. So we have KOL right here. And remember though, this is a tangent line, and whenever tangent meets radius, that's 90. So KOL is actually 90 degrees. And the reason is where whenever we have a tangent, right, meets radius. So that's the reason there. Tangent meets radius at 90 degrees right here. All right, so that's 90 degrees right there. Let's see the next one. This one? Oh, find the value of each of the following. Okay. LMN, LMN. So LMN, which is right here. So normally I would mark the angle LMN, this. That's LMN. And then as you could see, it is in a cyclic quad. If you're looking at it, this, this, this makes it a cyclic quad. So it's that angle that they asked for is supplementary to this. So if I'm able to find this angle right here, then if I do find that, then basically I could just easily subtract it from 180 to get that, right? So we could do it like that. So there are a number of things that we could do, as well as there's something else I think I would want to do, which is way easier. I could use the alternate segment where um, an angle between a chord and a tangent is equal to the angle in the alternate segment. So this is going to be 48. And then this is going to be 56 for this one. So I'm going to use alternate segment. It's less working. All right. So let's do the alternate segment. So it means then this is 48. And this is 56. All right. Alternate segment. So we're going to sum them up, right? So 56 plus 48. Where are we? They don't want a reason. So I'm just going to put 56 plus 48. We add them up and we're done. That's 104. This is 104 degrees. We're done. KLO. KLO. Where's K? KLO right here. All right. So they want right there. All right. So what we're going to do to find that is that all right, we can use the isosceles triangle. I will be using the isosceles triangle, right? So I'm going to need to find this little piece here, all right, which is the missing piece out of the 90 degrees here. This is a 90 degree. So if I say 90 minus the 48 and the 12, if I minus those, that little piece there is actually 30, right? So let me just fill it in quickly. That little piece is 30. Here's my eraser. Right here is 30. This is 30 right here. So what it does for me now, if I know that that is 30, is that it's going to give me some leverage because this angle here will be 42. That means this here is 42, right? So this would have been 42 overall, which means that the base angle of the isosceles triangle would be the same. And it is an isosceles because remember, this is center, this is radius, and this is another radius, same length. So 42 is what I'll just work with right there. And there are other ways you could find it, but I'm just trying to find the less, whatever. Angle MLK, MLK. Let's mark the angles. MLK. Let me clear the diagram a little bit. MLK. Where's M? MLK. Oh, all right. So we're finding all of that angle right there. All right. All right. So we could find it because so let me take off the things that we don't need right now. We don't need that for this one. All right. I need the 42. I need the 30. So MLK. You could look at it like this. MLK is an angle right now. It's a third angle because look at this. Let me just highlight this. This is one angle in that triangle. This is another angle in that triangle. You're asking me for this third one right here. So I'm just going to add those and take it from 180, right? So what I'm going to do for MLK, which is to say this, that angle, I'm just going to say 180 minus 48 plus 30. If I just take that, the response from that is actually the answer. So that's 102 degrees right there, right? So MLK is 102 degrees. Let me just drop it in. This is 102 degrees. Maybe this is the last one, I believe. It says K and M. K, N, M. So let's go for that. K, N, M. Oh, they want this angle here. And as you could see here, let me clear up this diagram again with all the unnecessary things, put on what we want. So this angle here is very important to it right now. All right. So I'm going to highlight the fact that this is a cyclic quad. All right, where the quadrilateral um, vertices are on the circumference. So opposite angles are supplementary. So this angle here, all I have to do is just to subtract 102. You're going to get about 78. All right. We're going to get 78. And that's just one way how you could have done it. There's another way you could have done the 78 because remember that this is 30. So the alternate segment here will take me here, which is 78 again. So there are multiple ways to get that. All right. So it's 78. 78. This angle is 78 degrees. And we're almost there. All right, let's see what this one is. All right, it says EFGH of 4 points. We're seeing 1, 2, 3, 4 points. The diagram below gives information on the distance and change it and the angles between points. All right, so we're seeing that. All right. Show that the value of x is equal to 29.5, correct to one decimal place. The value of x. Okay. Show that the value of x. All right. All right, so let us quickly read this information. It's giving us the information for here. All right. So what we're going to do basically is to see what they want. The first question want us to find the value of the angle KOL. KOL is actually this angle right here. Now, what we're going to do is just to put together some ideas. Remember, though, that this is a tangent line, and we're looking at the radius here for a circle. So radius meet tangent at 90 degrees. So it simply means that this angle here is 90 degrees. What it does for us, though, it's going to help us to understand what's going on because here it is. We have this triangle here that I'm intending to find that angle at O, basically. So what we're going to do here is to understand that if we should say 90 minus 12, 90 minus 12 plus 48, that's like 60. We're going to get 30. This is 30 here, which means that this entire angle here is 42. This angle is 42. That means this is 42 as well. So in an effort to find this third angle, all I'm going to do is to take 42 plus 42, isosceles triangle there, and then add those, take it from 180 degrees, and then I'll get that value right there. It's 96. So 96 is K. Oh, well, so KOL is 96 degrees. And the reason, one, I could say we looked at the fact that radius meet tangent. Yeah, radius meet tangent at 90 degrees helped. Also, the isosceles triangle. All right.